Hello YouTube, this is the Bob Father again with a follow-up video to the one that I made last weekend regarding the EG4 6500EX, which I purchased from Signature Solar in Sulphur Springs, Texas. My goal in the first video was to demonstrate that the solar inverter would run off the panels alone, and if it had enough voltage and amperage, and I demonstrated that there actually was voltage coming out of the thing. Matter of fact, it was 120 volts if you remember. And however, several viewers, which by the way gave me some great feedback, a couple of corrections, which I'm very appreciative of, and but a couple of you asked whether or not it would actually be able to sustain a load. And so that's the goal of this video. Just because I'm confident that it will. I have not tested it. I mean, you're gonna witness it right along with me. I have not tested it before making this video. So you're gonna have to suffer through some raw, unedited footage of what's going on here. But I commit to you that I have not tested this out already. I'm confident that it will. However, the doubt that's in my mind is because it's my understanding, according to Will Prowse, that the Will Prowse video, that that Signature Solar, or pardon me, EG4 is using their own proprietary operating system, and is not the same operating system as those in this machine's clones, and so that's what's cast a little bit of doubt in my mind as to whether or not we can actually sustain a load. But with that, just a reminder that dealing with solar is dangerous, and you should probably have an electrician. Whoa, we got somebody shooting off fireworks in the background there. I'd recommend that you use an electrician to do this kind of work, and this is for my purposes only. Thanks. The first thing I'd like to do is see if cleaning or a dusty panel really makes a difference. One of these panels that I've got hooked up here has been sitting outside the box in my garage and has collected a bunch of dust. And currently it is drawing 36.3 volts. I'll show you what I mean. This may have applicability later on. As you can see, it's a very sunny day. There's no clouds in the reflection today, but here's how dirty this panel is. Ooh, that's hot. So you can see there's a significant amount of dust on there. And we were at 36.3, and now, of course, you wouldn't be doing this up on your roof. You'd just be using a hose and some type of squeegee thing. But let's see if this may, oh my goodness, look at the steam coming off of that thing. There's the dirt. Let's go see if the clean panel made any difference on the voltmeter, on the multimeter. Well, it's small. It was a small change, and I realized there could have been, there's absolutely no cloud cover. But yeah, I made a slight difference. Went from 36.3 to 37 volts. So cleaning the panels did make a difference, albeit about 1% difference. Okay, with that, let's get on with the rest of it. All right, now that the panel cleaning test is out of the way, let's get on to what you really care about. All right, here's the setup. There's the EG4 6500EX. Last week in the first test, I had, 4 panels connected to it. This time, I've got a total of 8. 3 to the north here on the ground, 2 leaning up against the picnic table, and 3 on the south end for a total of 8. Notice that I'm using PV extension wires, 30 feet of them, and they are not connected to the panels right now. Not on the negative, nor is the extension wire connected to the positive just yet. With that, let's take a look at the inverter setup. The PV wires have been connected to the inverter, and they're running into the PV1 port. Notice that there are, once again, there are no batteries. That's the whole purpose of this test, load test, is to show that this unit can run loads off of or without a battery connected to it. And then coming off the line, one of the line outs are two 12-gauge wires running over to a common household receptacle with two loads connected to it. This hair dryer, which is 875 watts. And you're gonna have to take my word for it, because 6.5 times 120 volts, roughly roughly 700 watts coming from that Sawzall. So with that, let's test it out. The power button is in the off position. I'll just show you. That's the on position, that's the off position. Let's come over here and hook up our power so we can get the unit powered up. You didn't hear any fans. And as I go past it again, just to verify, no fans, and the LCD is not reading anything. Then we'll come over here, and as soon as we click or connect this PV wire to the panel, you will hear in the background, I will hear the inverter turning on, and sure enough it does. You can see and hear the fans running. You can also, okay, so that beep is the letting me know that the battery is not connected, and as you can see, it's flashing. I'm about to, and there's no output right now. You can see the solar panels are connected. Let's turn the unit on. There should be a click. Yep, there's the click. And you have the additional information regarding the throughput. And now there's 120 volts reading on the LCD. So let's get to the load test. Both of these devices should be able to run by themselves, but together I'm a little skeptical that they'll be able to do the whole load. But here's the first one. All right, so that was the Sawzall. Moving over to the hairdryer, which is a much bigger load, more than twice the load. It's already in the hottest position. Actually, I'm going to put it in the coolest position. There's the low fan. There's the high fan. And let's get it hot. There's the middle temperature, and there's the high temperature. Oh, it faulted. I don't know if I have enough juice. Nope. Yep, it faulted on me. Very interesting. The Sawzall had no problem, but the hair dryer did. Fascinating. Now keep in mind that hair dryer is 1,875. So let's do this. Let's wait a second. And once again, there was no predisposition as to what was going to happen here. Let's turn this off. Turn the unit off. And so the output, yep, the output is 0. Okay, let's turn it back on and see what happens. Oh, there we go. I'm going to turn. So I've turned it on the lowest power, or pardon me, the lowest heat setting. It's on the highest fan setting. And let's see how long it'll run. well, pardon me, I'm not going to bore you as to how long it'll run, but I'm just going to wait another, say, 10 seconds to see if it faults on us. Okay, well, as you can see, it's got a continuous load of 120 volts, and that hair dryer is still going. Now let's see what will happen when I add the Sawzall to the hair dryer. It should fault. And it didn't. So let's turn the hair dryer off. Okay, well, when that hair dryer was at its max fan speed and heat and temperature, highest temperature that it can crank out, it put this thing into a fault. But as you can see, I turned it back off. I turned it off and turned it back on, and then it's back to normal. And you heard because the hair dryer was still in the on position, it turned it back on, and I just took it off of the highest heat setting. So look, the point is that this thing can sustain a load, substantial load, and this is only 8 panels. If you have any questions, just let me know in the comments below.